What we're seeing today with the new image release from the James Webb Space Telescope is a picture of about 50 stars forming, and these stars are much like our sun. And so in some sense, if we were able to look back billions of years ago when our own solar system was forming, we would see something like this. In the upper right portion of the picture, you see red material. That's molecular hydrogen jets being blown away from the stars as they are forming. And in the lower left, you see glowing gas that's being lit up by other stars in this region. This is the closest star forming region to us. It's about 390 light years away, meaning the light that we're seeing now left 390 years ago. So on Earth, that was about 1633, which was coincidentally the same year that Galileo was going on trial for showing and talking about the Earth going around the sun rather than the other way around. The first year of Webb has been an amazing one, showing us that it's capable of doing what we built it for. In fact, it's exceeding those capabilities. And I like to remind people that all the things we've seen from it in this first year were done with plans before we knew how good it was going to be. So now everything we get from here out on Webb is going to be from plans knowing how good the telescope is. So I look forward to even more amazing discoveries. And one of the things I know we'll be doing is looking at planets around nearby stars, exoplanets, to study their atmospheres to see if they might be capable of hosting life. We just started that in the first year, and there's much more to come, and I'm really looking forward to that in the next couple of years. So Webb exceeds Hubble in some of its capabilities, in part because it has a bigger mirror than Hubble. Webb is optimized to work in infrared light, heat radiation to us, so it sees the universe a little differently than Hubble, which works in the visible. Importantly, it's not a replacement for Hubble. Astronomers use telescopes all across the electromagnetic spectrum, from X-rays, ultraviolet, visible, infrared, all the way out to the radio. And we need that to tell us how the universe works by studying it at different wavelengths. So Webb will hopefully become near and dear to people's hearts, just like Hubble was. But they tell us different things, and so they're both important.
The Rho-Ophiuchi Cloud Complex, a small star-forming region, is located 390 light-years away, the closest star-forming region to Earth. A chaotic scene resembling explosions frozen in time, this new image from NASA's James Webb Space Telescope displays a field of about 50 young stars, many of them similar in mass to our Sun. A region that would look black in visible light is revealed in the infrared with Webb's sensitive instruments. The detail in Webb's portrait of starbirth is unprecedented. The scene is dominated by a giant cavity that has been carved by a single star. That star, S1, is more massive than our Sun and emits ultraviolet photons that have carved out a bubble. The yellow-orange color comes from tiny sooty grains that astronomers call polycyclic aromatic hydrocarbons. Streamers of gas and dust form structures and textures unlike anything we have seen before. The striking large red vertical band is a protostellar outflow, twin powerful jets of material that occur during the early stages of star formation. The projecting cone is a result of material that's been ejected through the jet. The entire structure glows red due to molecular hydrogen being energized as material from the jets collides with interstellar gas. Like most young stars, young solar systems also form in multiples, and we can see several brand new solar systems making their way into the universe via the very same processes that shaped our own cosmic home. Planet-forming disks block the star's light, casting telltale shadows across space.